Hello everyone, my name is Jeremy Rodriguez. This is Chris Hunter, this is Aaron Harris, this is Matthew Bodakovich. We are team NTEM and our project is called Relentless. So what exactly is Relentless? Well, Relentless is a graphics and physics engine. It's capable of performing mathematical and graphical operations. And we also have support for networking and audio. So some of the individual features that our project contains, our engine contains, is a physics system, texture system, particle system, shader system, and you can see the list of the rest. We'll go ahead and talk a little bit about each one. I worked a little bit with the physics system with Chris, and the texture system, particle system, shader system, and everyone kind of works a little bit on everything as well. That's some input. Aaron, you can go ahead and talk about what you worked on.
I worked on doing our game views for the different game objects that we had and how that was set up and the architecture behind that, and our audio system as well. We used OpenAL, which if y'all were at the prototype, we mentioned some things about OpenAL that makes it really good to use for stuff like this. It has a lot of low-level functionality. It has good support for three-dimensional sound, which we'll get into.
I worked on the overall architecture of everything. I didn't really put the pieces together. The collision system, I did all that. We have intersection tests for spheres and planes and bounding boxes, and then compound shapes made up of those individual components. The view manager, which takes care of input and rendering to the screen, that was also me. And the animation system.
I worked on the networking and procedural content pretty much the entire time I had to basically integrate those with everything else, because anything that had to be sent from a server to a client had to be managed and sent over the wire, so that was fun. Winsock's not very fun.
I'd like to also point out that we do have plenty of unit tests on all these things. So like we were talking about, these are some of the technologies that we use. Like Aaron mentioned, OpenAL. All our graphics was implemented with OpenGL. We coded in C++, and we used such things as Winsock, Pthread, and the Windows layer.
No really external libraries, only STL, and then the thing listed here.
Right. Okay, so we're going to go ahead and try to figure out
Aaron's going to be taking over the server side of it, so you can show you kind of the mix.
So the purpose of our demo is to primarily show, we wanted to focus mainly on our networking support, server client side.
We showed the main features that we didn't show at the prototype.
So we showed features that right at the prototype, but we're showing other features here.
So whenever Aaron gets to go ahead and it's up.
All right, so like we said, we do have these boxes right here. They all have
Go through the boxes.
right, so we're just showing our physics capability, our networking support on things.
Where are you?
Our texture system.
Floating in the sky. We're giant metal suits of armor, just push boxes around.
I would like to say all the 3D models were created by scratch. Aaron created these 3D models.
This is
all
his
the textures and things.
This is his second set of models ever.
Right. He
First set was
completely. We introduced him to 3ds Max at the beginning of the semester, and he just ran with it. So we were kind of hoping to implement a scoring system because like with part of the system, we do have such things as blood splatter physics and stuff like that. But we decided for this purpose, we'd go ahead and just show mainly our networking support,
Which
and
was,
our physics.
the networking was extremely tricky because there's not we don't use any external libraries, so I had to create essentially sitting on top of WinSock, a socket library. So it manages UDP packets going back and forth. So it has support for request response, and for assured delivery. It can handle the issues with UDP, such as packets being out of order and that sort of thing. So I learned a lot of things I wish I had never had to learn about networking. and I can tell you right now, the school's network really, really hates me a lot.
Right. So like we said, we showed completely different features at prototypes. So this is kind of like part 2 of what we were showing for our advancement in what we were doing. So we still have all the features that we have at prototype.
This is like going towards a much larger goal in mind, so we're on a long road, and I think we've gotten a lot farther.
Right. So that's our demo for tonight.
Any
Is there
questions?
any questions?
Can you shoot him?
I wish. That's a
Dude,
really
that's
intimidating
weird.
looking weapon, isn't it? I mean, look how big it is.
we can push each other, does that count?
I have a question for Aaron Harris.
Yes.
What was your inspiration for the shape of the character?
The guy on the screen.
Yeah, a bear?
Not this time.
No, I mean, really, what was your inspiration? Like, what were you thinking as far as defense, offense, what? It kind of looks like a football player.
Because the prototype, my first foray into modeling a strictly biological character didn't work out very well. So I went with the medium road, kept my skills allowed, and did what you see there.
But biologically, you mean like moving joints and stuff?
Well, we have an animation system. It's just that that particular model is not rigged like the one in the prototype was. But what I mean by biological is like skin and like musculature and things like that. So it's pretty difficult to model a convincing looking human.
He literally started from the ground.
Yeah, well, you know,
So,
you gotta start somewhere.
John.
For those who missed the prototype, can you show them a picture of the fact that all you actually have?
I'm sorry.
A lot of people missed the prototype. Do you have the demo there, the prototype?
I believe I do have the demo. We'd have to take a minute to set it up actually, then.
It's
Put
okay.
it on afterward. We can show it to anyone individually after. I know the introduction was a little long on the prototype. So, John, you had your hand up earlier?
I wanted to ask, like, what all are you passing, like, over the network? In terms of, like, object location or
Positions
right.
and orientation.
Position and orientation.
Like-
the entire scene that you're rendering?
Not quite. The way it works is there's different, inside the engine there's essentially an object manager who gives us a unique handle on each entity that's in the system. And so we have a client and server variant of the thing that manages connections. And there's a separate thread that sits there and listens for connections continuously and reads packets that get sent in. Packets as an object is a serialized thing. I had to make my own serialization interface, and it just uses IO stream stuff. So iStream, OStream to read, to parse things from, essentially you have to deal with what's called network byte order and host byte order. Windows is reversed from everything else in the world. So you have to put it in backwards and then put it back together backwards if you want cross-platform support. So the simplest thing is though that since the server and client handle all the physics and such the same way, all I have to give them is position and orientation of, say, each of these boxes. And then for the players, I just have to give them, like, again, positions and angles. So with something like this, it doesn't have to send, like, try and serialize the entire object. Each object is responsible for its own serialization.
I know what was difficult for you, and I know now what was difficult for Aaron. I would like to ask Chris Hunter what was difficult for him in this project, and also Jeremy. What did you find?
Intersection test took like about a month and a half.
What?
The intersection test, like collision detection. And then incorporating that with the physics system, that took about 2 weeks. Those were the most difficult things I had to deal with.
How about you?
That's our octree that organizes, groups the objects, so it doesn't have to check every object against everything for collision. And as you can see, it expanded to where he was because it was originally just in that area. But it's most of the splitting is concentrated where the main objects are.
Right, there's a lot of things going on in the background technically. I know visually it might not seem like there's a lot. The hardest thing for me, particularly besides like physics, like he was saying, was learning the OpenGL graphics library. Because it's like everything's from scratch at that point. You can't just load up a WinForm, you have to create it. Handling messages, stuff like that. I was kind of all new to that. So just being able to get down to low-level programming. And, yes?
If you go near the boxes, they seem to be moving. Is it intentional or the rendering issue?
There's actually a little Schrodinger's cat in each box.
It's just
The physics.
It's very roughed out. This one doesn't. The original physics system, when I first coded it and it was a testing environment, they did mass and momentum calculation and also angular momentum calculation. This, when we put it together, it's just basically hard-coded values, so it still twitches a little bit.
So you're working on
oh, sorry. Yes?
So there's always interesting physics bugs in games, things shooting around, doing odd stuff. What was the most interesting bug you encountered
This was going to
working on your physics engine?
Well, the very first box that I ever dropped in the scene, it landed perfectly, it sat down, and then it just slowly started shaking and just vanished.
It was scary, to say the least, from a visual standpoint. We didn't know what was
The most terrifying thing.
But the animation system was way worse with weird bugs, like just
as you can see. Our prototype, which we'll go ahead and show.
Yeah.
Do we have that?
Do we have audio? Or,
Yeah, it's right on that.
We'll probably do that after the final group if you want to see the prototype.
Right, we'll go ahead and load up our board. Are there any more questions?
I want to ask one.
Yeah, John.
Like, you guys said there's a long road ahead. I noticed there's use of like global lighting right now. What's your plans for lighting?
For lighting and stuff? Right now, right, like we have global lighting. I've been messing with that along with the shader system and all, and really I just need to kind of talk with these guys and see.
Our main focus was really just physics moving around.
Right, physics and networking for this.
More on gameplay than making it pretty.
Right.
It's me again. Do you plan on developing this game or taking what you learned on this game and developing something else in which your projection?
A good deal of this will go into the next one, but some
Right.
of it's getting scrapped and removed because we learned that was a bad way to do things.
Right, the objects in this are just purely for the purpose of showing the capability of our engine. So,
There's definitely more things that we learned how not to do than
right,
how to do through, I don't want to say trial and error, but a lot of
it
it.
actually started going back and rewriting. So, it was continuing on.
Sometimes it's not worth it to rewrite it. Sometimes it's better to start on, take what you learn. Start it.
All right, well, thank